So in this video, we're going to look at, it's called a glide reflection. So for a glide reflection, we do two things. So we're going to explore the glide reflections or a slide and flip. So we do two things. We slide or we translate the figure and then we flip it or we reflect it. So again, these are isometries. So again, isometry means that the original shape, the pre-image, and the image are congruent, which means that the side lengths are preserved, the angle measures are preserved, the lines that are parallel are still parallel in the image, so those are preserved. The lines that were perpendicular are still perpendicular in the image, so those are preserved. And so when we're doing a combination of transformations, or in fact, any combination of transformations that are isometries will also result in an isometry. So in order to do a glide reflection, we need two things. We need a directional error or vector to define the translation, and we also need a line of reflection. Okay, so this is an example. So use design one, our same design, to translate that x plus 1, y minus 3. Okay, so this is my vector. And again, that means I'm moving 1 to the right and 3 down, or by the vector shown here. And here's the vector to show that you're going 1 right, 3 down, and then reflected over the line x equals 2. And we're going to complete the table below that shows the coordinates of each of the points after each transformation. Discuss if there's a mathematical way to come up with the ordered pairs for the reflection after the translation has been done. Okay, so what we're going to do is we're going to take each point. So I'm going to take A and I'm going to first translate it this way. So I'm moving again, right 1 and then 3 down. So I take this point and I go right 1, 3 down, and that's my first point, A prime. And I'm going to do that first for all these points, and then I'm going to do the reflection. So B, the same thing. I'm going to go right 1 and then down 3 to get my B. I'm going to do A, so I'm going to go, or sorry, H. So H, I'm going to do right 1 and then down 3 to get my new H. C, I'm going to go right 1 and then down 3 from that point, and this is my new C. Okay, so I'm just doing that translation again, where I'm moving it from each point. I'm counting how they said that I'm adding 1 to the X, which means I'm going right 1, and then I'm going minus 3 to the Y, which means I'm going down 3. So for D, I'm going right 1 and then down 3 to get D. E, I'm going right 1 and then down 3 to get E prime. Okay, F, I'm going right 1 and then down 1, 2, 3. Okay, G, I'm going right 1 and then down 3. And then I'm going to connect it to H. So this is my translation. This is my slide. So I did this part that I'm translating every point 1 to the right and 3 down. And again, when I do that, I count from that point and count what they said. So from that point, I count right 1, down 3, and then make a new point. So after that, if I'm doing a glide reflection, then I do the reflection part. So now I'm going to reflect it over the line x equals 2. Okay, so x equals 2, remember, is a vertical line that goes through the x value of 2. So x equals 2. Is this vertical line at x equals 2. And I am going to reflect my new image. So this image, after I translate it, I'm reflecting the translated image over this line. Okay. And when we do our reflections again, what we're doing is we count to the line of reflection and we count the same distance to the other side. So I see A is 1 to the right of my line. So I'm going to come my line and I'm going to go 1 to the left. Okay, H is 1, 2. And so I come to my line and then I'm going to go 1, 2 to the left. And we did this when we did our reflections. So B is 1 to the right of the line, so I'm going to come to the line and do 1 to the left. Okay, C, I count 1, 2, 3, 4 to the line, and so I'm going to count 1, 2, 3, 4 to the other side. Okay, so D from this line of reflection is 1, 2, 3, 4, and then I'm going to count 1, 2, 3, 4. Okay, E prime is 1, 2, 3, and then I can count 1, 2, 3 on the other side. And then F prime is 1, 2, 3 as well. So I'm going to count 1, 2, 3 to get my F prime. G prime is here, and that's 1, 2 from the line. So 1, 2. So this is my G prime. Okay, and sorry, for each of these, I should be putting double primes just to indicate that they're different. And so this is my final image. And so this is the answer that I'm going to give. Okay, so for my image, I have A double prime. And so A now, okay, so again, it's harder to read because of all these lines. This is my origin. So A starting there is at 1, -1. B double prime, my new B is at 1, 5. My new C is at -2, 5. My new D is at -2, 2. My new E, which is here, is at -1, 2. My F, which is here, is -1, 4. My G, which is this point here, is at 0 because this is my y-axis, and then 1, 2, 3, 4. So G is at 0, 4. And then H is at 0, -1. And that would be my new image. I'm sorry, this is kind of hard to read the scale with this diagram on here. But this would be my new image. This would be my pre-image. If we kind of compare the ordered pairs, we can see like the Y values. We again move 3 down for each one. So for each Y value, we subtracted 3 from it. So we have like 2 - 3 is -1, 8 - 3 is 5, 5 - 3 is 2. But then when we reflected it, we first, again, added 1 to all the x's. So we went 2 + 1 is 3, but then we reflected it over this line, x = 2. And so now you can see it's at 1. And same thing, B, when we moved it over right 1, like our original B prime, which is here, was at 2, but then when we reflected it, it became at 1. And then 5, we moved it right 1, but then when we reflected it, it was 1, 2, 3, 4 from the line. So when we reflect it 4, we get to -2. And so we're kind of subtracting 3 from each of those. So for the x values, there's not like a easy way to come up with the ordered pair. You probably will need to translate it and then reflect it versus like coming up with a rule for what we did. So that is how we do a glide reflection.